The mystery of Martian spiders, Araneiform terrain explained. Welcome my darlings. Today, we're diving into one of the most fascinating and eerie landscapes in our solar system, the spiders of Mars. No, we're not talking about actual spiders, but something equally strange, a terrain on Mars known as Araneiform terrain. These formations look like hundreds of spiders crawling across the red planet's surface, but what are they really, and how did they form? Scientists believe these features are caused by processes unique to Mars' extreme environment, with low pressure and frigid temperatures. Today, we'll break down how these formations came to be, the experiments simulating them here on Earth, and why they matter for understanding Mars. If you're a space enthusiast or just curious about alien landscapes, stick around. Let's start with the basics. What exactly are we looking at when we talk about Araneiform terrain? The word Araneiform literally means spider-like, and these formations are found in Mars' southern polar regions. They're created by the unique interaction between CO2 ice and the Martian soil. Mars has extremely cold temperatures, reaching -301 degrees Fahrenheit, -185 degrees Celsius, and a very thin atmosphere mostly composed of carbon dioxide. During the Martian winter, CO2 forms ice on the surface. When spring comes, the sun's warmth causes the ice to sublimate, meaning it turns directly from a solid to a gas. However, the gas doesn't have anywhere to go. It builds up pressure beneath the surface, eventually breaking through, and in doing so, it carves out these spider-like channels in the soil. So in a way, these spiders are scars left by the escaping gas. To replicate this process on Earth, scientists built a simulation chamber mimicking Mars' extreme conditions. They used simulated Martian soil, a type of regolith, then covered it with a layer of CO2 ice. By heating the mixture with a lamp, mimicking the sun's rays, they recreated the sublimation process. What they found was fascinating. The ice transformed directly into gas and etched spider-like patterns in the soil, just like those observed on Mars. Think of it this way, it's like shaking a soda bottle. The gas inside is under pressure, and once you pop the cap, it escapes quickly. Similarly, the CO2 gas on Mars builds up pressure and escapes explosively, leaving behind these unique formations. Key terminologies. 1. Araneiform terrain, spider-like surface features on Mars created by the sublimation of CO2 ice. 2. Sublimation, the process of a solid turning directly into a gas without becoming liquid. 3. Simulated Martian soil, Earth-based materials used to mimic the composition and properties of Mars soil for experiments. 3. Demo or hands-on section, 7 o'clock 9 o'clock. Now, let's explore a hands-on example to help visualize this Martian process. While we can't recreate Mars' extreme environment in our homes, we can perform a simplified experiment. You'll need 1. A small tray of sand to represent Martian soil. 2. Some dry ice, which is frozen CO2, be sure to handle with gloves. 3. A heat source, such as a lamp or hairdryer. Place the dry ice on top of the sand, then use the lamp to gently heat it from a distance. You'll start to notice that the dry ice sublimates, leaving small marks in the sand, much like the spiders on Mars. While this won't produce the exact effect seen on Mars, it gives a clear idea of how the trapped gas carves through the surface, leaving behind patterns. So, what does this tell us about Mars and our exploration of other planets? Araneiform terrain gives us crucial insights into the climate and seasonal changes on Mars. Understanding how CO2 behaves on the planet's surface helps scientists predict future missions and uncover more about its geology. Plus, knowing how these formations occur could help us determine if similar processes exist on other icy worlds, like Saturn's moon Enceladus or Jupiter's moon Europa. Summary of main points. 1. Araneiform terrain is a unique feature of Mars caused by the sublimation of CO2 ice. 2. Scientists have recreated this process on Earth, showing how gas builds up and escapes from beneath the surface, forming spider-like patterns. 3. These discoveries help us better understand Martian climate and geological activity, which is key for future exploration. If you enjoyed learning about the strange, spider-like formations on Mars, don't forget to like, subscribe, and hit the notification bell for more videos on space exploration. Have any burning questions about Mars or other planets? Drop them in the comments below, and I'll be sure to respond.